So in this lecture, we will discuss a transformation method to improve the prediction power of in the data set. So this is another data pre-processing method, and this is very commonly used in real data analysis. So data transformation. So the idea of transforming data is to make sure your new data fits the model better than the original data. Okay? So you could use data transformation to standardize the variable. For example, if you have a column called age and another column called salary, and typically salary has a large value compared to the age column. Okay, so in order to make sure these two columns are comparable in some predictive model, then we need to standardize the variables. So you could say each column has mean 0 and standard deviation 1. And sometimes we can use the data transformation to stabilize the variance. Okay, so you can do some transformation of your target variable or transformation of some huge input variables. And transformation also helpful if we want to handle non-linearity. So for example, if we know y is nonlinear in x1, okay, then we can try to transform x1 as x1 squared or x1 cubed and then run a regression using y and x1 squared and x1 cubed. So to handle non-linearity. We can also handle the non-normality and skewness in the variables. So the left skewed or right skewed, we can use transformation. And sometimes if we have class variable, and like job is a class variable, you have different kinds of jobs, and we may need to create some dummy variable for some predictive models, for example, linear regression. Then in this case, we can use data transformation to add dummy variables. And sometimes we can also use that to create an interaction variable. Like say x1 times x2 will be an interaction variable. So in SAS Enterprise Miner, we have a node called transform variable. So make sure we need to impute missing values before transform variables. Because if there's a missing value in the data, the transform variable will have some troubles. Here is just an illustration of some common transformations of the interval variables. So you could use log transformation. In that sense, you just take log of your input variable x1. So the original regression model will be y equals beta 0 plus beta 1 x1. So now it's log x1. You can use square root. You can use the exponential of your input variable. That's to say you take log of the target variable. You can use standardize. And the second option is to use binding. So binding, for example, you could have an interval variable, and this interval variable has many different values. And you may want to group these values into different buckets. So this can improve the predictive power in some examples. And third one is called best power transformation. So basically you do a power transformation to maximize the normality of the data or maximize the correlation with the target. And then the machine will automatically figure out which transformation is the best for each variable. Okay? And you can also specify your own transformation by doing that manually. So let's take a look how can we do that in our example. So again, we will use the HMEQ data set. And remember last time we impute the data, and now we just add a node called transformation, variable transform. And then we will make sure to do that before we run the input node. So connect the input node to the transform variable. And then from the transform variable, you can see different options for each variable. So default method is none. So you can specify what's your default method for interval inputs or the class inputs. All right. So let's specify as an example. Let's use the input as best. So best means best power transformation for the input variable. And let's use optimal binding for the target. And for the class input, we just create a dummy variable, and target we just use none. Okay, that's just an illustration of the options. And let's run the transform variable. And after it's done, we'll be able to see what's the best power transformation for each interval variables. So here we use best for the interval input. All right, so it's finished. So click results. And here you will see a best transformation I square. So that'll be this table here. So this table tells you for the input called age, that's the input. Remember, we do the imputation before we transform variables. So for this variable age, they try the different options of the transformation. Okay, so compute the variable, and then they will give you what's the best one based on the I square. So the I square measures the correlation between the target variable and the transformed variables. And we'll choose the optimal one as the one with the largest R square. So for example, in the CL age variable, the optimal one is optimal binning. Okay? And it's similar for other variables. So that's called best for the transformation of the interval variables in our case. So this is the option to specify from the property manual of the transformation methods. You can also specify this transformation manually by click the formulas. So you can create your own transformation. Just click formulas. So maybe we need to wait for a while, and then you will see a window pop up, and then you want to you may be able to specify the transformation manually. All right, so here's the formulas window. So you can click. So here's all the variables we have. And you can manually specify which variable you want to add, or you want to transform. For example, debt income ratio, if you click this one, it's going to give you the shape of your data set for the column debt to income ratio. Okay, so you can specify manually what kind of transformation you're going to use. So if we click this one, here on the left, that's our create. Click this one to add the transformation. And now you see you can add a transformation, say, let's just an example, IMP debt to income ratio. So that's a variable we have. And let's create a variable of debt to income ratio square. So that's a square. And then we just click OK. So after we click OK, basically you have a new column called transform 0. So trans 0 means that's a new data you added, new column. This new column is original imputed debt income ratio take square. So that will be added to your column, and that's a new input variable for the remaining analysis. Okay? So that's how you manually specify transformations. And this could be useful in the real data analysis if you want to add a nonlinear term or manually add some interactions, for example, or nonlinear terms or some other transformations. All right, so that's the end of the discussion of the transform variables nodes.